This video goes through the portfolio optimization functionality. So although portfolio optimization is well known to most of you, what we will see during the 4 extensive Python examples is that there are so many different things that you can do with it in the investment analysis module. So that's why that there will be several new concepts and details that we will present here. So basically, the basic formulation that we use in the efficient frontier optimization or with expected return constraints is something where we try to minimize the portfolio's risk over the portfolio exposures. And basically with these portfolio exposures, it's necessary for us to separate between market values and exposures to be able to handle derivatives in an elegant way. So this is something that you can read about in the portfolio construction and risk management book. Besides that, we will always account for transaction costs, so that's what we recommend that you do, because of course these are also very, very important and enters directly into the expected return equation of your portfolio's expected return. We also, if you have, let's say, some cash investments where you pay a management fee or something like that, you can also subtract the holding cost, because usually when we do the market simulation, we implement views and things like that. It's related to the market directly, and then we come to the implementation where we will have some holding cost and some transaction costs. And then finally, of course, we will have this self-financing constraint where we don't wait for money to come into the portfolio before we actually trade what we want to do. We can have a number of different constraints on the exposures, and this is something that we'll go through soon. For the risk measures, currently we have CVaR variance or lower semi-absolute deviation. For all practical purposes, we recommend that you use CVaR, or if you want lower semi-absolute deviation, because these things, they operate directly on joint Monte Carlo scenarios and probability vectors. So basically they work no matter how complex our simulations are, while mean variance tries to reduce the market to a elliptical distribution, which is quite unrealistic compared to what we see in reality. Okay, so it's also possible to optimize the portfolio with a risk target and even tracking error constraints. And this is actually what most of the sophisticated investors they do. And this is something that we'll talk about at the end of the presentation, and then just go through the functionality here for the basic cases. Because everything with constraints and the portfolio object and optimization object and things like this, it will be the same. It's just different methods if you want to do tracking error optimization or target risk optimization that we will see later. Okay, so for the constraints, here's just a list of the most common ones. It's not actually all of them that are listed here. To see all the constraints, you can read the documentation. But basically, we have the individual bounds, which is just upper or lower bounds for the individual exposures. We can have group bounds. So basically, if we have more than one exposure and we want to bound the exposure of this specific group, we can have maximum buy and sell bounds, which you can see here. So here you also have group ratio bounds, and that is formulated in this way. So although the constraints are formulated as linear, you can see that we can actually formulate many different ratios and things like this, because we just use these linear constraints in a clever way under the hood basically. There's also this group proportion bounds constraint, because the ratio constraints, it's actually the ratio of one exposure over another, or the ratio of one group over another group. But usually when people work with these things, they want actually to use this group proportion bounds. So let's say, for instance, that you have some fixed income part in your portfolio, and you define something as investment grade and something as high yield. Then maybe you say something like that the high yield proportion should at most be 50% of the entire fixed income, or whichever other upper or lower bound you want. So this is what you have formulated here. But you can usually make an equivalent formulation between these two constraints, and this is also something that we will see in the examples. Okay, so then we have net exposure bounds, and this is basically if we take and sum all of the different exposures, we can put a upper or lower bound on that. And then finally, in relation to the exposures sum, we also have gross exposure. So basically, you can see this as the leverage. So instead of taking the sign into account, we just look at the absolute values, and this is usually how funds they count leverage, because it doesn't really matter if you short a future or you buy a future. it will count as leverage in the total exposure, and you can bound that also. Then finally, we have some max turnover constraints. So this is basically from the individual exposures. You can define how much turnover you want. But in practice, if you have properly specified transaction cost, if you include parameter uncertainty and things like this, then this max turnover constraint should not be necessary, because it's an artificial constraint on the exposures basically. So it's much better that you specify the problem correctly, and then you should just get the optimal exposures given the actual constraints. So there are also other constraints that are not shown here mathematically. It can be something like metrics constraints. So basically, if you have some exposures that you can measure, let's say some factor exposure or some ESG metric or something like that, then you can include it also. And for these holding costs, some people also want to have an upper or lower bound on the holding cost in their portfolio. And this is also something that we implement. It's not written here because there's already a lot on this page. There are two different ways that you can specify constraints. So basically, one will be just to write it in Python using the methods from the portfolio class. And this is something that we will see. But there's also a method in portfolio class which is called set constraints from tables. And basically, it allows you to specify the different vectors in CSV files and then specify the constraints afterwards. So basically, you can see here we have a CSV file called constraints vectors, and the first thing you can do is to have a lower and upper bound, just individual exposures. Then you can define different groups. So here, for instance, I call it alternatives. So this is private equity, infrastructure, real estate, and hedge funds. Here I also define something as investment grade and high yield. And then finally, I have some of these metrics bounds, which I call ESG in this case. So let's say that at some point you are able to measure the CO2 from each of the different exposures that you have. Well, then you can bound that on your portfolio. So far, I actually have not seen anyone who actually have all these ESG numbers, but it can also be used for something like factor exposure or some other metric that you can come up with. Some people, they have illiquidity metrics and things like this, so you can include it here and then specify the value from each individual exposure. All right, so then you have this constraints list, and basically you will see it takes different arguments, and then you say which kind of bound is it. And basically the name of the bound, this is what you can find on the documentation. So basically, if the method is set group bounds, then we just call it group bounds instead of having this set, which is there in the portfolio class. And then you say, okay, which group is it? It's the one that you call alternative here. So of course there's a cross check that you actually define alternative groups. And then here you can see that you have different arguments. And then basically, how do we know how many arguments a specific bound takes? Well, it's also given in the documentation. So basically here for group bounds, it's just the group and then the lower and upper bound. And here you can set, for example, no lower bound in this case. For group ratio and group proportion bounds, well, there are two groups, and then you have the upper lower bound. Cross exposure is just one argument, and then you have these ESG or metrics bounds, and then actually we also show you how you can do holding costs here if you want. So okay, let's go into the code and see some of these things, how they are done. So these are the examples for the investment analysis module, so you find it here, and we will have 4 different examples. The first one that we'll go through is basically this overview that it did previously. So we will just focus on the portfolio optimization parts, basically just to recap these things. Because this part with loading the data and simulating P&L or using P&L from the investment simulation module, this is something that you can find in the other videos.